In today's tutorial, we're going to be building a scene with a cluster of twisting arrow snakes flying over a landscape. We're going to be using some features that were added in RayTK version 0.40, so just make sure you're using at least that version. Check the video description for download link. The scene is going to be composed of two elements, a landscape and a group of arrow shapes that move across it. We'll start by creating a basic landscape using a noise field, and then we're going to add a 3D arrow with some waviness, and then we're going to make it move across the landscape with the camera following along, and then we're going to combine a few different techniques to make 4 different variations of the snake, and then we're going to be twisting the whole group of snakes, and then we're going to apply a pattern to the landscape for some detail on the surface. Then we'll set up materials and lighting, and then finally we'll do some animation and then optimize things a bit at the end. Start by downloading the Toolkit Talks. We're going to be using some features that were added in RayTK version 0.40, so just make sure you're using at least that version. Check the video description for a download link. Once you have it downloaded, drop the Toolkit Talks into your project. I like to do that at the root outside of the main project comp, but you can put it wherever you want. I do it at the root so that it doesn't show lots of data connection lines in the main scene network, because that can make things a little bit confusing to look at. Once that's done, head over to where you're going to be building your scene, and we'll get started by setting up a renderer. Open RayTK's palette with the Alt-R shortcut, and we're going to create a RayMarch Render 3D. Then create a null top connected to the first output so you can see the rendered image. With the renderer selected, open RayTK's Editor Tools menu with Alt-Shift-R, and then under Add Camera, choose Look at Camera. We're going to be adjusting the position of the camera later on, so we can just leave it on the defaults for now. The next step is to create the landscape. To do that, we'll be using a plane with some fields offsetting its surface. Rather than going for a super realistic landscape, we're going to keep things kind of abstract with some geometric patterns and enough waviness to make it feel like terrain. Open the palette with Alt-R and create a plain SDF, and connect that to the first input on the renderer. We aren't seeing anything yet because the camera is currently intersecting the plane. So head over to the camera, and then for the Y part of the position, let's bring that up to around 5. Then I'm just going to reorganize things a little bit. Next, we need to add some variation to the offset of the plane so that it isn't perfectly flat. So to do that, let's create a noise field. And then we're going to connect it to the offset input on the plane SDF. And when you do that, just make sure to mouse over so that you can see which one you're connecting it to. The order of the inputs may change in different versions of the toolkit, which is why it's important to verify that you're connecting to the right one. So let's connect that up to the noise field. And that's doing at least something, but it seems to only be using the x-axis with everything staying the same along the depth z-axis there. The type of noise that's selected by default here is Simplex 2D, which means that it's only using 2 of the axes. So we need to tell it which way it should face. So to do that, let's change the axis setting here from Z to Y. So now it's facing the Y-axis, meaning it's using the X and the Z. We're getting a bunch of render glitches though, so we're going to need to drop the amplitude down fairly low. So let's bring that down maybe around 0.2 or so. Then for the scale, let's increase all parts of that up to around 3, so it's more spread out. Now we can move on to creating the arrow snakes that are going to be moving across the landscape. To create the arrow shape, we're going to start with a 2D SDF. So create an arrow SDF 2D. To give us a sense of what's going on with this SDF, let's set up a temporary preview render. Unfortunately, in version 0.40, there's a bug that breaks the inspector tool, but if you're in 0.41 or later, you can just click the inspect parameter here, and it'll pull up the inspector where you can preview that SDF. But since that's not working in this version, we can just build our own really quick. So with the arrow SDF selected, open the editor tools with Alt-Shift-R, and then we're going to choose Colorize 2D SDF. Then select the Colorize, open the editor tools again, click Add Render 2D. Then open the editor tools again and choose Append Null. Then just going to move this a little bit. So now we've got a little preview of the SDF. And then for the zoom, let's just pull that back a bit, maybe 0.5, so we get a wider view. At least in this version of the toolkit, the arrow SDF 2D works by specifying 2 endpoints. So there's the from point, which is the base of the arrow, and then the to point, which is the tip. In future versions, I might add a simplified mode here that just lets you pick an axis and a height. So if you see an option like that, you can try just using that instead. We're going to be taking this 2D SDF and revolving it around an axis to create our 3D shape. So we need to have it centered and aligned to the y-axis. So to do that, let's set the x part of the from point to 0, and then we're going to do the same to the to point. So now it's centered on the y-axis. And we can keep the y settings at -0.5 and 0.5 for now. We're going to be making some adjustments to the other stuff in a little bit. So now let's take this 2D SDF and revolve it to create a 3D shape. So with the arrow SDF selected, open the editor tools with Alt-Shift-R and choose Revolve. Then we need to combine this with the landscape. So I'm going to select both the revolve that we just created and the plane SDF and open the editor tools again. And under Arrange SDFs, choose Simple Union. And I'm using an arrange here instead of just a simple combine, so that it gives us an easy way to kind of toggle the two off if you want, as well as to position things using these translate settings. So we can even just switch that on because we're going to be using it in a little bit. Just going to move this, and then we can connect it up to our renderer. And then let's go back to looking at that rendered output. What we're seeing now is a 3D arrow on the z-axis, but it's partially embedded in the landscape and it's pointing towards the camera instead of away from it. So we need to flip it. So back at our arrow over here, we could do this with a flip operator, or we can just swap the point settings. So I'm just going to do that. On the from point, we're going to change that to 0.5, and then the to point is going to be -0.5. So now it's facing forwards like we want it to. It's still stuck in the landscape though, so let's adjust that over on our arrange. So on the arrange, we can take the parameters on the first translate, so the Y part, raise that up to around 1. So now it's hovering over the landscape, though it's a little bit hard to see with the view that we currently have, but we'll fix that in a bit. So now let's go back over to our arrow so we can adjust some of the settings there. For the thickness, which is the thickness of the base, let's drop that down a little bit to maybe 0.15 or so. So just a little bit thinner there. Then for the head thickness, let's drop that down to around 0.3. Then for the head ratio, let's raise that up to around 2. That kind of lengthens that tip of the arrow. Now let's lengthen the base, and we can do that with the Y part of the from point here. So try adjusting that, and we're going to see that larger values make it longer. So let's bring that up to around 2.8. We're going to do some tuning on that a little bit later on. With that set up, let's add some waviness and prepare the snake for movement across the landscape. For the waviness, we can use a translate with a sine wave. Open the palette, and we're going to create a translate, and then insert that after the revolve. And let's rename that Snake Wave Translate. And again, you can use whatever naming style you like, but we're going to be referring back to this later on, so it'll be helpful to have it have a useful name. Now let's organize things a little bit, just make some room over here. On the translate, let's change the mode from XYZ distance to just direction and distance, since we're only going to be doing this wave along one axis. And we can actually keep the default direction here with 1, 0, 0, since that means moving across the x-axis, which is what we want. Now create a wave field, and we're going to connect that to the distance input on the translate. And again, make sure to mouse over, be sure that you're getting the right one. So distance right there. And then for the axis here, we want to set that to Z. And let's rename that wave field to Snake Wave Field. So we are getting some kind of waviness, but it's way too intense and we're getting a lot of render glitches. Let's drop the amplitude down to around 0.2. So just a little bit of a wave there. And then for the period, we can bring that up to around 3, so it's fairly spread out. The next step is to prepare for moving the snake across the landscape. When we do that, we want that wave that's adding the waviness there to stay in place as the snake moves across it. So rather than moving that wave, we're going to actually move the SDF and keep that wave in the same place. And to do that, let's create another translate. Insert that before the one we just created. And this one, let's call Snake Offset. And I'm going to move that over here. Similar to what we did with the other one, let's change the translate mode to direction and distance. But for this one, we want it moving on the z-axis, so let's change the direction there to 0, 0, and 1. So now we've got this distance parameter, and we can try moving that, and so it's moving the snake along the z-axis. But it's moving it backwards for positive numbers, and then forward for negative numbers. So that may seem a bit odd, but it is actually consistent with how SOPs handle the z-axis. So that's why it is that way. So let's set it back to 0 for now. One thing that you may notice when you move the snake is that while the snake is moving, the camera is not. And that means that once it moves further than just a little distance, it's going to be out of frame and we're not going to see it anymore. One option to deal with that would be to use an expression to link the look at camera's Z position to the snake's distance. So let's go over to that snake offset, right click the distance parameter here, and choose copy parameter. Then we can go over to our camera, expand that position parameter, and then for just the Z part, and make sure just to use that one part, not the entire parameter, right click that and choose paste reference. And immediately there's a problem and everything disappears. So the issue here is that we are using a look at camera, which means that it tries to face a particular point in space. And right now that point is set to 0, 0, 0. But the snake is currently at an offset of 0 on the z-axis. So it's sitting on the z-axis trying to look down at a point that's also on the z-axis, so it's getting confused. Now we had previously had that z at the default setting of 5, and that seemed to work okay. So we can change our expression here to add +5 at the end. So that kind of works. And if we go over to our snake translate and try changing that distance there, it's doing something, but it still ends up pointing in the wrong direction and we lose the snake. And this is actually the same issue that we had with the camera when we first changed that, which is that it's kind of staying at the point that it's looking at is staying stationary at 0. And even though the camera position is following the snake, it's still trying to look down at that point, no matter how far it gets away on the z-axis. And to fix that, we could do something on the camera with the look at position using another expression there. But fortunately, there is a better alternative to all of this that was introduced in version 0.40. So go back to our camera, and for that expression, let's just set that back to what it used to be of just 5. And then we can close that. Intuitively, you might think that we can just create a translate operator and insert that after the camera. So if we try doing that, then it's not giving us an error, but it doesn't seem to be doing anything. It is actually doing something, it's just definitely not doing what you would expect it to do. So rather than being applied to the position of the camera, it's being applied to the UV coordinates of the pixel that's being rendered. In future versions of the toolkit, I may add some validation that would show some sort of error here indicating that it's not supported, but there are some really obscure scenarios where that is actually useful, so I'm not sure what I'm going to do with that. So instead, let's remove that, and we can create a camera transform. and insert that after the camera. On this, for the translate, if we try changing that, so it is not only moving the position of the camera, but it's also impacting where the look at point is to go along with that motion. So let's go back over to that snake offset, and again, right-click the distance parameter, choose copy parameter. Then go over to our cameraTransform, expand that translate parameter, right-click the Z part, and then choose paste reference. In 0.41 and later, this is going to be renamed to position translate, but it's effectively the same thing as what we see here. Now, if we go over to our snake offset and change the distance there, we can see how it follows along with the snake and it remains looking kind of in the right direction relative to where it's been moved to. On the cameraTransform, in 0.41 and later, there's going to be a setting that you can use if you want to have it not do that adjusting the look at as well, but by default it should behave just like this. So before we continue, let's take a look at a potential issue that is going to be showing up in the renderer. So if you keep moving this all the way down and keep going, you may come to a point where the world kind of gets cut off and ends. And if you go further beyond that, then eventually everything disappears. So this may not be happening depending on what settings you have on the renderer, but at least in version 0.40 and earlier, this setting is going to be on by default. So to fix that, let's go over to our renderer. And then on the settings page, I'm going to find this limit box setting and switch that off. In 0.41 and later, this is going to be off by default, so you probably don't need to do that. But in 0.40, you do. Limit box is a way to tell the renderer to give up on rays that go outside of a certain area, and just assuming that they aren't going to hit anything. Now that works great when the camera is stationary near the origin, but it doesn't account for cameras that are moving far from that point. I usually tend to leave the camera kind of staying near the origin point, often stationary. So in that context, limit box makes sense, but for this scene, it makes more sense to move the camera, so we need to switch that off. And in version 0.41 and later, this is going to be off by default. Next up, we're going to add some additional snakes to give this one some friends. So there are lots of different ways that we can approach this, so let's first figure out our goals. So we want to have 4 of them. They should be arranged in a way that doesn't look like a regular pattern. They should be able to cross over each other at least some of the time. And they should be able to have different wave periods for their wiggling. So one option would be to use instancing, where we could give each one a different position offset and then use variables and fields to vary the wave period for each instance. That would allow them to overlap as much as we want, but it does mean doing 4 times as much work compared to just having a single one. Another option would be to do something like modulo polar, which would be way more efficient, but it does mean that they would be arranged in a ring and they couldn't overlap at all. A radial clone would allow overlap, but it would still be in a ring and it would still be 4 times as much work. So ultimately, I think the best option here is to do a little bit of copy and paste combined with some mirroring. First, let's do just a little bit of renaming. So on both of these, the snake wave field and the snake wave translate, just add a 1 to the end. Then select both of those and copy and paste. If we didn't do that renaming beforehand, we would end up with the second one getting automatically renamed to have a 1 at the end, which I would find kind of confusing, so that's why we did it beforehand. Select both of the translates here, and then open the editor tools with Alt-Shift-R, and then we're going to do Arrange SDFs Simple Union. And let's rename that to Snake Arrange. And just going to move that over here. So now let's connect that up to the renderer. So now we have 2 of them, but they are sitting in exactly the same place with the same settings, so we can't see anything yet. So on the snake arrange here, we're going to switch on Enable Translate. Then for the first one, for the translate parameter there, move it to the left, so around negative 0.9 or so. And for the other one, let's move it a little bit to the right, so maybe 0.8 or something. And let's also move it back on the z-axis a little bit. So for the z part of translate 2, we're going to increase that to maybe 1.1 or so. Then for the second wave, let's increase the period there to around 4. So not too much different, but enough for some variation. Then we can go over to our snake offset, try changing that there. And we now have 2 different snakes that are wiggling at different rates, and they're positioned in a little bit of an organic layout. But all of this is still at the cost of doing twice the work of the snake SDF. So I'm just going to set the position back to 0 there. To get from 2 snakes to 4, we can sort of cheat a bit. Rather than making 2 more copies of both of these groups of operators, we can add some reflects that will mirror the 2 of them that we already have. That way we are still only doing double the work, but we end up seeing 4 snakes. And then we're going to make some adjustments to make it look less like it's mirrored. So create a reflect and insert it after the first transform there. This is already giving us problems there because it's cutting off the snake and you can really clearly see that it's being mirrored. We can use the offset parameter here to move them apart. And maybe just bring that up to about 1. They do still really look like they are mirrors of each other though, so we're going to need to do something about that. Right now, the reflect is just using the x-axis, but we can change the angle that that reflection plane is facing. change the direction here from X positive to custom. And it's actually going to do the same thing by default because that's what the default setting is here. For the Y part of that direction, bring that up to maybe 0.6. So that gives it a little bit of an angle. You could also try doing some Z, but if we try combining that with motion along the snake offset there, we're going to see that eventually it's going to collide and then they're both going to disappear. And then even in the other direction, it's going to disappear into the landscape and just get further and further away. So we need to leave the Z part of that direction at 0. Next, we can go over to our translate that's doing the waviness. And for this one, we can do something similar, changing the direction that it's wiggling so that it's not, perfectly perpendicular to that cut plane. For that one, let's drop down the Y part of that direction to maybe negative 0.8. Now if we go back over to our snake offset and move that, then it's a little bit less obvious that they are total mirrors of each other. But we can still do more to improve that. Let's use another translate to move one of them backwards and then one of them forwards, and that way they won't be right next to each other. Create another translate and insert that before the first one here. And let's call this one Snake Shift 1. Change the translate mode here to direction and distance. And then we're going to change the direction to 0, 0, 1. So it's moving on just the Z-axis. Next, we need to have it apply a different amount of offset to each side of that reflection. Select the reflect here and open the editor tools with Alt-Shift-R, and then under reference variable, choose side sign. This gives us a variable that is going to be -1 on one side of that cut plane and then +1 on the other side. To be able to control how much we're offsetting, let's take that variable reference, select it, and open the editor tools again, and then choose Rescale Field Simple. And then we're going to take that and connect it to the distance input on Snake Shift 1. That gives us a slider here for the multiply that we can use to control how much they are offset relative to each other. Just that however you see fit. I think I'm going to go with maybe -1.2. So that the middle one, the one that's closer to the middle, is further ahead. So now let's do the same things that we did here for the other snake pair. So let's select the Snake Shift 1 and the reflect and the variable reference and the rescale field. And with all of those selected, copy and paste. It's important to do that as one combined operation rather than copying the individual parts so that the editor knows to update the connection of that variable reference that it points to the new reflect instead of the old one. So now let's wire that up to our new translate here and then make sure our reflect is inserted there. And for this one, let's change the direction of that mirroring plane to maybe negative 0.2. And for the second rescale field here that is controlling separation, we can bring that closer and maybe 0.4. So it's less extreme of an offset than the other pair. Then we can go over to our snake arrange and move things around a little bit. For the one that is on the left side, let's bring it in a little bit, maybe negative 0.7. And for the one that's on the right, actually we can keep that one where it is. So for Z, maybe negative 0.7. So now that gives us 4 snakes, but we're still only doing twice the work as if we just had one. Now that we have all of the elements in our scene, let's take a minute to arrange the composition a little bit. Right now, the view of the snakes is pretty tight, and they're fairly short, and they're clustered together. So let's get a wider view and go over to our look at camera. And then for the FOV angle, let's bring that up to 80. Then let's position the snakes kind of relative to that frame on our range. And I'm actually just going to rename this here to scene arrange, since it's arranging the contents of the scene. And we can use the Z part of the translate here to move those forward a bit, so maybe negative 0.8. So the one that's furthest is kind of pretty close to the edge of the frame, but not all the way. Now let's make those tails longer. And we can do that over on our arrow here. For the Y part of that from point, which is the base point of the arrow, we can increase that to something fairly high, maybe 4.8, 4.9. And maybe even higher to like 6. Sort of up to you whether you want to see the back ends of the snakes or just have them kind of always go all the way out of frame. Now, and then let's adjust the snake positioning a little bit. So on our snake arrange, we can take that second one, pull them back a bit further, maybe 2.5, and that will space things out a bit more. For the other one, maybe even bring it back a little bit, maybe 0.9. With all of our snakes in place, let's add some extra twisting on top of everything that we already have. To do that, let's create an axis rotate, and we're going to insert that between the snake arrange and the scene arrange. Make sure that the axis there is set to Z, and then we're going to create a wave field. make sure it's set to Z as well, and connect it up to the rotation amount input on the axis rotate. It'll take a second while it recompiles the shader. And then for the amplitude here, we can bring that up fairly high, maybe even like 90 or so. And for the period, we'll bring that way higher to maybe even like 10. So now we can go over to our snake offset, and let's try moving that. So as things go, we get some really interesting motions there. But we are getting some points where that's kind of intersecting the ground and that some of the things are disappearing. So let's go back over to our scene range. And for the second part, the landscape, just bring that down to maybe -1. You could also bring the snakes up if you want, but I think this keeps things framed the way they are. So that's about it for the snakes. So let's go back to our landscape. The noise field that we're currently using is giving the land some variation, but it's still kind of boring. So let's use a pattern to add some detail to it. So open the palette and create a hexagonal weave pattern. There are a few different ones named similarly, so just make sure you're getting that one. You can try swapping out different ones later on. To preview what this looks like, if you're in 0.41 or later, you can click the Inspect button to open the Inspector tool, but let's just build a quick little preview render. So just with that selected, open the Editor Tools with Alt-Shift-R, add Render 2D, open the Editor Tools again, append null, and switch on the viewer there. This pattern gives us a combination of these two layers where we've got circular holes arranged in a hexagonal grid, and then the two layers kind of weave in and out of each other. We need to take this field and combine it with our noise field. Select both of those and open the Editor Tools with Alt-Shift-R, and then under Combine Fields, and make sure to use Combine and not Composite, we're going to choose Add. So then try connecting this up to the plane SDF. And we're going to get an error there. If you mouse over that, we're going to see a message here about how the input does not support return type vec4. The exact wording of this error might change in future releases to be a little bit more clear, but general idea is that that offset input is just expecting a field that produces a single number, and somehow this combined fields is now producing a vector. So the plain SDF doesn't really know what to do with that. Even though the noise field here is producing just a single number, and it was fine when we had it connected directly, we're now combining that with this pattern, and the pattern is producing vectors. So the combined fields, trying to be helpful, is expanding that noise field into a vector to produce that combined result. To convert to just a single number, let's select the pattern here, open the Editor Tools with Alt-Shift-R, and then under toVector part, we're going to choose the first option, X or red, and then connect that to the combined fields. And once that finishes compiling, we should be good to go. And just going to take a look back at the render there. And head back over here. Okay. So that is certainly doing something, but it seems like there are a lot of render glitches, and we're getting something similar to what we had with the noise field when we first set it up, where things seem to be really stretched out along the z-axis. So I'm going to make some room over here. When we had a similar issue with the noise field, it was because the noise pattern is based in 2 dimensions and it was facing z, so using x and y by default. And we fixed that with this axis parameter here. But the hexagonal weave pattern doesn't have a parameter for that. So it just assumes that you want to be using x and y. So how can we fix that? With the pattern selected, open the editor tools with Alt-Shift-R, and then under Project Plane, here we're going to choose XZ, and then connect that up to the vector to float. And those could be in either order, it doesn't necessarily have to be before or after that. So once that finishes compiling, we're going to see something going on there, but still kind of hard to tell what's going on. So at least we can tell that things are kind of arranged along the X and Z plane, but there's tons of render glitches in there, and the pattern's really small, and lots of issues there. First, let's just adjust the scale on that. So the size here, we're going to bring that up to like 0.5, so spread the pattern out a bit. But again, we still have all these glitches and holes in it and chaos going on down there. So one of the issues there is that we are applying way too much offset here. So we need to scale down those numbers. So one way to do that, if we wanted to, would be to adjust the color settings here, and then, you know, just the red channel there if we adjust those numbers down. But it's going to be easier to just add another operator to do the scaling. So select the vector to float, and then open the editor tools, and then choose Rescale Field Simple, and then connect that in to the combine. Once that's done compiling, we can use this multiply here to bring that way down. So I'm going to set that to around 0.15. Then for the pattern, let's make a few adjustments there now that things are kind of in a more reasonable state. For the size, I'm actually going to bring that up a bit to maybe 0.7 so that we can see it a little bit better. And then let's bring up the blending. So this is going to be how smooth those transitions are between the different layers. So this is actually going to do 2 things. One, it's going to help out with those render glitches because it's going to make those transitions more gradual, which means that the renderer is better able to understand what's going on. And it's also going to have some interesting aesthetic effects. So especially if we bring that up to like pretty high values, maybe even like 0.4. So that's looking fairly good. So now let's take this pattern and let's add some variation to it so that it's not just constantly the same across the whole landscape. On the pattern here, we can try adjusting this thickness, and you can see how it gives us a nice range of different kinds of looks. So when it's all the way down, you get those really thin little outlines, and then when it's really high, you get more of like and then when it's really high, you get this sort of like interlocking circle look. So instead of just using one setting everywhere on the landscape, let's use a wave to vary it. So create a wave field, and then find the thickness input on the pattern, connect that up. Again, making sure to mouse over to be certain that you have the right one. It's going to do its thing and compile. And these compile times are going to be a little bit longer as our scene is relatively complex at this point, but some of the optimization that we do later on should help with that. Let's bring the period of this wave all the way up to like 8 or so it's fairly spread out. And to figure out a good range, one option would be to use a rescale field, and then we could, pick the specific numbers that we want to work with. But just for the sake of time, I'm going to just drop down the amplitude all the way down to 0, and then let's pick a good midpoint. And I think that's maybe like 0.5. And then bring the amplitude up so we get a nice range there. Something around 0.3 looks pretty good. Then we get some areas where we get more of that thin outline, and then some areas where we get more of that interlocking pattern. So this looks okay, but it's still kind of looks a little bit odd that it's so evenly across the x-axis, and especially if we change the phase on that, we can see it's moving there. It's very obviously just side to side, which I don't personally like that much. So let's add in an axis rotate on the wave. It's going to do its thing and recompile. And then we can change the rotate parameter there however you like. I'm going to go with something like -115, something around there. So now if we go to the wave field and change the phase there, it's a little bit less obvious what's going on, especially if this is moving relatively slow. All right, so let's leave things there until we animate later on. Now it's time to get our materials and lighting set up. This is going to be fairly similar to what we've done in other recent tutorials. We're going to use two different materials here, though, one for the snakes and one for the landscape, and that way we can add some shininess and different coloring to the snakes, and then have the landscape be more kind of subdued, even color. Now, because of the complexity of the scene, we're going to build out these materials before we wire them in. So open the palette and create a modular mat. Normally you could also create that by selecting the SDF operator and opening editor tools, but we're just going to build it out here quick. So with that modular mat selected, open the editor tools, and then under add diffuse, choose Oren Nair. And then with the modular mat selected again, let's do add specular, GGX. This is a fairly common combination of shading that I tend to use. We're going to do just a little quick optimization here, even though we're going to be focusing on that more later on, but it's particularly impactful for these. So on the diffuse contrib, we're going to right-click the method parameter and then choose toggle read only, and then we're going to do the same thing on specular contrib. Toggle read only. All right, so that kind of locks those choices in place, which helps the shader compiler optimize things more. So now that we have that set up, let's connect that in between the plain SDF and our scene range. So just connect that up to the second input there. And when it's done doing its thing, we will before we get too much into tuning those, let's just set up a light instead of using the default one that's built into the renderer. My normal go-to here would be a point light, but similar to what we have with the camera, with the kind of main contents of the scene moving pretty far along the z-axis, the point light would end up getting further and further away unless we were to have it move along with the camera. But rather than do all that, we can instead just use a directional light. So select the renderer there, open the editor tools for Alt-Shift-R, and then under Add Light, we're going to choose Directional Light. So this is equivalent to the distant light in a regular light comp, or what you might be familiar from other 3D software. So now you can use the properties of the direction there to change how much it's facing each different axis. So just that however you like. You can also use the rotate here, which is in degrees, angle, rotation, or you can use some combination of the two. So I'm going with, let's see, -0.7 for X in the direction, and 1 for Y, and then for Z, let's keep that at maybe 0.4 or 0.3. All right, so now let's go back to our materials. And to make things a little bit clearer, select the specular contrib and just toggle off this enable setting, just so we're only seeing the diffuse. So now on the diffuse, let's bring up the albedo to 1. And then for the roughness, let's bring that up to maybe 0.7, something like that. Then on the specular, switch that back on. And let's pick 2 different colors for the different shading elements. So for the diffuse, I'm going to go with kind of a pale green color. And then for the specular, I'm going to do a pale orange, so sort of like a tan or beige, but fairly light, fairly desaturated. Maybe even on the diffuse, bring the saturation down further. It's just a little bit of color there. So now let's dial in the settings on the specular. For the roughness, let's bring that up. Maybe not all the way up, so maybe like 0.9, so that we're getting a lot less of those highlights. And then for now, let's bring that up to 0.8 or so. So that gives us some variation in the shading on the landscape, but not too much, and the landscape isn't really as much the focus, so that's okay. So now let's take the diffuse and shading and the modular matte, copy those, paste them. I'm going to move those over here. And I'm going to connect those up for the snakes. So connect to the axis rotate that's doing the twisting, and then connect that up to our scene arrange. And it looks like I did not connect that up correctly there. So once that's done, When that's done recompiling, we can dial in settings here. For diffuse, let's bring the roughness down, like 0.4 on the diffuse. Going to change the color there to be more of a blue and actually bring up the saturation relatively high. And then for the specular, I could bring the saturation way up. Something like that. And then for the roughness on the specular, we can bring that down so we get a nice shiny highlight there. So you can just spend some time tuning these, getting them to look the way that you want, however you like to have those. When you're done with that, we can move on to the animation. We're only going to be animating 2 parameters here. So for the landscape, we're going to animate the phase of that pattern. So let's go over to the wave field here that is connected into our pattern there. And with that selected, open the editor tools with Alt-Shift-R. And then under Animate with Speed, we're going to choose Phase. And just move that over here. You could try adjusting the speed there. I actually kind of like the default here with like 0.1 and then a multiplier of 1. But if you want to make it move faster or slower, adjust those however you like. Then let's move over to our snake offset. And do something similar for this one. So select it, Alt-Shift-R, and then under Animate with Speed, we're going to choose Distance and make sure you're using that one. If things get kind of weird, it's possible that you did the wrong one. You can just undo and then get the right one. So let's use that there, and then we can bring the speed up there to maybe like the base speed there to like 1.3. And again, since things are kind of flipped there, we need to hit the reverse here so that they're going forward. So now that we actually have some animation going on, you're going to start to get a sense of what the frame rate is. Depending on your GPU, things might be running fine at 60 FPS, but if you're getting lower frame rates, or if you just want to be more efficient, there are some steps that we can take to optimize things. We did a little bit of that earlier with the materials, but we're going to take it further now. I'm not going to get into a ton of detail about what these techniques do and why they work, but if you're interested in learning more about that, you can check out the videos in the Optimizing RayTK series. So we already did that over here on our shading elements in our materials, locking in that method parameter there. So now let's head over to the field that is controlling the pattern, the shifting there. So on the wave field here, select that, and we're going to use a new shortcut added in 0.40. So select that, open the editor tools, Alt-Shift-R, and then under Lock Param, I'm going to choose Wave. So it'll take a second there. And this is going to do basically the same thing that we did on the diffuse and specular, where it's making one of those parameters read-only. The shortcut in the editor tools will show you the specific parameters where that's going to be most useful. And so that should help a little bit. And that tool in version 0.40 Similar to the issue with like this, my weird little parameter panel over here, is it doesn't support doing it to multiple operators at the same time, but starting in 0.41 it does. So that's just a little shortcut to keep in mind. So now let's go over to our combined fields where we're mixing in that pattern and the noise. So on this one, we're just going to switch on this optimize setting. So this is kind of a specialized shortcut that this operator provides for doing something similar to what we did manually locking those parameters. And we can do something similar on the two arrange operators. So over on our snake arrange, it has an optimized parameter too, switch that on. One really important thing to note here is that while that parameter is on, any change to the parameters is going to cause the shader to recompile. So it's important to make sure to switch that off before you go making changes. So then let's go over to our scene range, and we can do the same thing there. So scene range and lock things in with that optimized setting. Then let's go over to where we have the axis rotate here. That's doing that twisting. So select that, open the editor tools. Under lock param, choose wave, or you could right click the wave parameter there and make it do that with toggle read only. So then let's go over to where we have these two copies of the pairs of snakes, and we can do something similar. So this one I'll just do it manually. So right click that wave parameter, do toggle read only, and then we're going to do the same thing on the other one. In 0.41, that editor tool shortcut, the lock param, does support doing multiple at the same time, so you could select both and do it, and that will be a little bit faster. So that should help a good bit. There are a bunch of other smaller places where we could do the same thing. If you want to do like the axis on the plane or the direction setting on the reflects or various other places, but the ones that we covered should have the most impact. Before we wrap up, there's one more small issue that we should address. You may notice that on the back edge of those arrows, we're getting some kind of nasty aliasing there. Now, one solution to that would be to increase the anti-aliasing on the renderer, but that's going to have a pretty significant impact on performance, so let's try a cheaper alternative. Head over to where we're creating that arrow SDF, and open the palette and create a round operator, and then we're going to insert that right after the revolve. Then connect that up to the translate here. Once that's done, recompiling the shader, we can bring up that rounding amount just a little bit, and that will help smooth out those back edges. Now we get a more nicely defined highlight on that edge without the aliasing. And that's it for our scene. So to recap, we are starting with a 2D arrow SDF, which we are revolving around an axis to create a 3D shape. We're then using a translate to offset that along the z-axis. Then we are taking a translate with a sine wave to cause a wiggling back and forth. We're then reflecting that to create a second snake for the same price as just having a single one. We're then using a variable from that reflect with another translate to offset one of the sides forward and the other one back so that it looks less like it's mirrored. Then we have another copy of that whole arrangement with a different wavelength and different offsetting to give us 4 nice variations, only for the price of doing 2 of them. Then we are combining the 2 of those using an arrange with a little bit of positioning using the translate settings here. Then we're applying some twisting to the whole group of snakes using an axis rotate with a sine wave. Then we are adding a landscape with a plain SDF, which is being offset by a combination of 2 different fields. One of them is a noise field, which gives us just the variation on the landscape. And the other one is a hexagonal weave pattern, which is providing the detail on the surface there. We're also using a wave field to modify the properties of that across the surface, which is giving it that variation. Then we are applying modular materials to both of these using diffuse and specular shading with different settings on the snakes and on the landscape to give it some different looks there. We're then combining those with another arrange with a little bit more positioning in the translate settings. And then finally, we are rendering that out with ArrayMarch Render 3D. And we are using the new cameraTransform operator to make the camera move along with the snakes as they move over the landscape without impacting the direction that the camera is facing, so it stays looking at the right spot relative to the snakes. And we're using a directional light instead of a point light so that we get a more consistent view without having to have the light move along with the camera. If you have a reasonably powerful GPU on the renderer, you can try switching on shadows. That will give it a little bit more of a look like these are actually shapes moving over a landscape instead of just, shapes in front of another shape. And depending on your GPU, that may be okay in terms of performance. But if it does slow things down, then you can switch that off. There are lots of other things that you could try with this, like using different initial SDFs. Instead of using that arrow with a revolve, you could try like a hexagonal prism or a series of cubes or a polyhedron or something else. You could also use a field to assign color patterns onto the surface of the snakes, like maybe having stripes that move along them. You could also try different kinds of fields to control the landscape and use different patterns on the surface there. And you could even try using different blending modes between the snakes and the landscape to make them kind of merge together somewhat. Just remember that before you change any settings on the arrange here, just flip off this optimize setting. Otherwise, it's going to have to recompile every time that you change any of the settings. And when you're done making changes, you can switch that back on. Anyways, I look forward to seeing what you all do with this. If you post on social media, use the RayTK hashtag. And at least on Instagram, you can tag me directly if there's stuff that you want to show off, since their hashtag search is unreliable, and sometimes I don't see the stuff that just has the hashtag. Thanks for watching. If you want to support RayTK development, subscribe to my Patreon. You'll get early access to tutorials, exclusive scene file downloads, and lots of other stuff. And even if you don't want to pay, you can still subscribe there for free as a way to get announcements about the toolkit. Feel free to reach out if you have any questions. I'll put links in the video description for different ways to do that. Anyways, thanks for watching, and make sure to like and subscribe.